Hello viewers, in today's class we are going to discuss another important problem from integral inequalities. So here we have a very nice problem in which we are given an integral I which is from 0 to 1 and dx over 1 plus x raised to pi by 2, and we are given this condition, and that is the inequality log of k is less than this integral I, and this integral I is less than this number m. Then we have to find the value of e raised to I times k times m, right, where I is the complex number, that is iota, and I square is equal to 1, right, and k and m belongs to the set of real numbers. So here we have to make use of this inequality to find out the values of k and m, right? And once we find out the value of k and m, we can easily calculate this quantity, that is e raised to I k m, right? So let us start and let us see the limits of integration. So here the limits of integration are from 0 to 1. It means this x, it belongs to the interval 0 comma 1, right? So here we have x which lies between 0 and 1. It means it is less than 1, right? So we'll start with this inequality, that is x square is less than x raised to pi by 2, because here we have 1 plus x raised to pi by 2. So we introduce x raised to pi by 2 by this inequality. Now see, x is a number which is less than 1, and here we have x raised to 2, and here we have x raised to pi by 2. Now see, the approximate value of pi is 3.14, so the value of pi by 2 is 3.14 over 2, that is 1.57, right? So here we have x square less than x raised to 1.57. Now since x is a number which is less than 1, or it lies between 0 and 1, so higher is the power of x, then the number is less than x raised to 1.57, right? So here 2 is greater than 1.57, and x belongs to the interval 0 comma 1, right? So higher is the exponent, and when x lies between 0 and 1, then lesser is the number, right? So x square should be less than x raised to 1.57. So now we can extend this inequality, that is x square is less than x raised to pi by 2, and these two quantities are further less than x raised to 1, right? Now see, here we have the exponent 2, here we have pi by 2 which is 1.57, and here we have 1, right? So out of these three numbers, this 1 is the minimum number, right? So power of x, that is x raised to 1, should be greater than these two numbers, because x lies between 0 and 1. It means x is less than 1. So now what we will do, we'll add 1 throughout this inequality. So we have 1 plus x square, because we want to get this term 1 plus x raised to pi by 2. So 1 plus x square is less than 1 plus x raised to pi by 2, that is less than 1 plus x, right? Okay, now taking the reciprocal of these three quantities, what we will get, we'll get 1 plus 1 over 1 plus x square, 1 over 1 plus x raised to pi by 2, and here we have 1 over 1 plus x, right? Now see the direction of the inequalities. So here when we take the reciprocal of these three terms, then the direction of the inequality gets reversed. So now we can also rewrite this inequality as 1 over 1 plus x, that is less than 1 over 1 plus x raised to pi by 2, and here we have 1 over 1 plus x square, right? So now we have obtained the integrand which appears in this integral I, right? So now we'll integrate throughout from 0 to 1. So we'll get 0 to 1, and here we have dx, here we have 0 to 1 dx, and here we have 0 to 1 dx, right? So now this integral is our integral I, and here we have 0 to 1 1 over 1 plus x. So the integral of 1 over 1 plus x is a log of 1 plus x, and the limits are from 0 to 1. This is less than I, replacing this integral by I, and here we have 1 over 1 plus x square. So this is a direct result from indefinite integrals. So the indefinite integral of 1 over 1 plus x square is tan inverse x. So the limits are from 0 to 1. So here we have used the standard result, that is integral, that is 1 over a plus x dx is equal to log of a plus x. So this is the natural log, and here a is some real number, right? And here we have used the integral that is 1 over a square plus x square dx is 1 over a tan inverse x over a. So these two results are used in this expression and in this expression, right? So here we have a is equal to 1 in this case, and here also we have a is equal to 1, right? Now substituting the limits, so we have log of 1 plus 1 minus log of 1 plus 0, that is less than I. Then here we have tan inverse 1 minus tan inverse 0. So this is log of 2, and here we have log of 1, and log of 1 is equal to 0, and here we have I, and tan inverse 1 is pi by 4, and tan inverse 0 is 0. So here we have used the fact that tan pi by 4 is equal to 1. So tan inverse 1 is equal to pi by 4, and tan 0 is equal to 0. So tan inverse 0 is equal to 0, right? So now from here we have log of 2 less than I, that is less than pi by 4, right? And now if we compare this inequality with this one, that is log of k less than I and less than m, and comparing these two inequalities, we'll get k is equal to 2 and m is equal to pi by 4, right? And now we can find out the value of this expression. So we have e raised to I times k times m is I times k, k is 2, and m is pi by 4. So this is e raised to, this is 2 to the 4. So we have I pi by 2. So now to get the value of this expression, we'll use the Euler's result. So e raised to I theta is cos theta plus I sine theta. So here we have theta is equal to pi by 2. So we have cos of pi by 2 plus I sine pi by 2, right? So cos pi by 2 is cos 90 degrees, that is 0, and sine 90 is 1. So we have 0 plus I, that is equal to I, right? So the value of this expression is equal to I.